Let's talk about common tasks performed by data scientist or machine learning engineer in their day-to-day job. So the three common tasks are classification, clustering, and regression. We'll look at each one of these in detail, but I'm not going to cover the math part of it. I'm just going to explain the concept with a simple example. Okay, let's move on to classification first. Classification is basically assigning a known class or label to each of the input record. Okay, let's imagine that we have a data set. The data set has X number of records. Then our task is to assign a known class or label to each one of those records. Okay, each of those records could indicate anything like physical or virtual entity, or it could be anything else. Our task is to assign one of the known class or label to that record. Okay, if you see this example, we have a bunch of records and we have categorized them or classified them into 4 different quadrants here. Okay, so this is actually what we are trying to do. Okay, so in this example, we have 4 different classes and we have classified these data into these 4 different classes. We could have any number of classes. Okay, so our task is to assign one of the class to each of those records. Okay, so that is our task. And let's make this concrete with some examples. Let's imagine that we have a data set and each record in the data set is an image of either cat or a dog. Then our task is to classify whether that image is a dog image or a cat image. So in this case, we have 2 known labels. One is cat and another one is dog. And our task is to assign one of these 2 labels to each of those records. Okay, the first image could be a dog image and the second image could be a cat image and so on. Okay, so that is what we need to do. And it could be something different as well. For example, our input data might represent medical report. So now based on that report, we want to classify whether the tumor is malignant or benign. Malignant mean it is cancerous, benign mean it is not cancerous. Okay, so we might need to do that. Or we have a bunch of record. Each record represent a handwritten letter or a digit. Then our task is to classify the correct digital version of that. So if the handwritten letter looks like an A, then we should be able to classify that as A. If it looks like number 8, for example, then we should be able to classify that as number 8. So that is another type of classification. Or another example is vehicle type. For example, we might have a data. That data represent various factors about the vehicle. For example, it will include things like the weight of the vehicle, height of the vehicle, its tire size and stuff like that. Based on that, we should be able to classify whether it is a car, truck or something else. Okay, so all these things comes under classification. So this is the classification task. Now let's move on to next task, which is clustering. Clustering is similar to classification, but the difference is here we don't have any known label or class. We will group the input record based on their similarities. Okay, if you see this diagram here, we can see that we have grouped records in the close proximity into one cluster or one group, and we have 4 different groups here. So here we are just grouping them based on their similarity. We are not giving them any name or anything, or we are not assigning any labels to them. We are simply grouping records based on their similarities. Okay, so this will be useful in many instances. If you take an example of grouping Netflix users, if we group the users based on what they like and what is their interests, then it will be useful. It will be useful because, let's say for example, we have grouped users based on what genre they like and what kind of movies they prefer to watch. Then if one of the users in a group rated one of the movie very highly after watching it, then we can recommend that movie to other people in the same group. Okay, so this is why clustering will be useful. And we could also do clustering on customer by their shopping behavior. For example, some customers might be impulsive buyers, some customer will only buy if there is a bargain. So if you group those kind of customers, then we will be able to do targeted marketing for those customers. And similarly, we can use clustering for insurance anomaly detection as well. If it is a normal claim, for example, it might form a cluster. Anything that sits outside of the cluster might be a fraudulent claim. So we may need to look at it. Okay, so that is another example for clustering. Now let's move on to the third type of task, which is regression. Regression is again very similar to classification, but the difference is rather than assigning a class or a label to the input record, the task here is to predict the continuous numeric value for each of the input record. Okay, so again this is explained better with an example. Okay, so let's say for example on the x-axis here we have size of the house and various different aspects of the house. Okay, so as we go along the x-axis, the house gets better and it is becoming a better area and stuff like that, for example. On the y-axis we are actually plotting the price of the house. So we can easily see that as the house size increases, the price also goes up. Okay, so if we know the size of the house, then we will be able to predict the price of the house. Okay, so the price will not be anything like a label or class, it will be a numeric value, and that is what we are trying to do with regression. With regression, using the input data, we are trying to predict a continuous numeric value that will represent anything like house price or temperature. We can actually predict the temperature from day and the geographical information, and also it could be things like height. We could actually predict the height from age and other factors of a student like gender and things like that. So this is what we are doing with regression. Okay, so with classification we are classifying the input record to one of the known classes, but in regression we are actually predicting a continuous numeric value that will represent anything like this, like house price, temperature and height and so on. Okay, I hope this is clear, and this is all I wanted to cover in this video. Thank you.